Hi guys, let's start a new chapter. This new chapter is called distance formula. That's chapter number 28 in your textbook. So let's look at it. Before we solve questions, so let's look at some basic concept. I have drawn a basic graph and let's try and find the distance between A and B. So this is point A, this is point B, this is 3 and this is -2. So this is 3 units on this side, this is 2 units on this side. So the total distance will be 1, 2, 3, 4, 5. So this is 5 units. Next, the distance between C and D. C is on the y-axis, D is also on the y-axis. This is 1 unit, 2 units and 3 units because this is 3 units. CE. CE is also on a straight line and it is 1 unit and 2 units. Perfect. Now what if, so all these were straight lines which were along one of these lines marked on the graph. Now in case I need to find the distance between OE, how would I figure that out? This chapter helps us understand how to figure that out. In any case, we already know that if I can join E with this point here, let's name this point, let's say L, this is O and this is E. What angle is this? This is 90 degree. So as soon as I see a right angle triangle, what comes to my mind first is the Pythagoras theorem, which means OE square will be equal to OL square plus EL square. So this is exactly the formula that we use for calculating distance, and the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square root, which means this is the distance between any 2 points, and those 2 points are, let's say these points are, so this is the distance between P and Q, and let's say P1 is x1 y1 and Q is x2 y2. So these are 2 points, x1 y1 and x2 y2, and PQ is given by x2 minus x1 whole square plus y2 minus y1 whole square and the square root of it. So for us, let's look at this question. Here OL is given equal to 2 units, EL is also given equal to 2 units. So OE square will be equal to 2 square plus 2 square, which is 4 plus 4, that's 8. Therefore OE will be equal to square root of 8, which is 2 root 2 units. Perfect. Now we apply this using the Pythagoras theorem. Now let's solve the same question using the distance formula, which is nothing but application of Pythagoras theorem. Now what are the coordinates of E? Coordinates of E are 2 on the x-axis and 2 on the y-axis. So this is 2, 2. And what are the coordinates of O? These are 0 and 0. So now let's apply the distance formula. x2. So in this case, if I'm taking E as my first point and O as my second point, so let's apply x2 minus x1, which is 0 minus 2 whole square, plus again y2 minus y1, which is 0 minus 2 whole square, the square root of it. So 0 minus 2 is -2 whole square, that's 4, plus 0 minus 2 is again -2 whole square is 4, which is square root of 8, which is equal to 2 root 2 units. So basically using this formula, if you remember, we can figure out any distance between any 2 given points. So x2 minus x1 whole square plus y2 minus y1 whole square. So let's try and solve some questions and let's see how it works. So I am on question number 1, part 1. Find the distance between the following pairs of points. So the first pair of, this is part 1 and this is -3, 6 and 2, -6. So here let me take this as x1, y1 and let me take this as x2, y2. So we know distance will be equal to x2 minus x1 whole square plus y2 minus y1 whole square, the square root of this. So let's look at this. In this case, x2 is 2, so 2 minus -3 whole square plus -6 minus 6 whole square and the square root of this. So 2 minus 3 is 5 plus 3, which means 5 square plus negative 6 minus 6, that's negative 12 square root, which means this is 25 and this is 144, which makes it square root of 169, which is 13 units. So the distance between these two given points is 13 units. Let's look at the next question. The next question we're doing is part 4, root 3 plus 1, 1 and 0 root 3. Next thing to ask is, does it make a difference as if I take this x1 or I take this as x2? Does it make a difference? No, it doesn't make any difference, but the point will have to be x2, y2. You cannot take the point as x2, y1. Yeah, that's obvious. So this is x2, y2 and this is x1, y1. Let's see if it makes any difference to our life. So distance will be equal to x2 minus x1 whole square plus y2 minus y1 whole square, the square root of it. So the first one is root 3 plus 1 minus 0 whole square plus 1 minus root 3 whole square, the square root of it. So root 3 plus 1 whole square will be, this is in the form a plus b whole square, which means a square plus b square plus 2ab. Perfect. And then this one will be a minus b whole square, which means a square plus b square minus 2ab. Done. This and this gets cancelled. So I'm left with 3 plus 1, 4 plus 1, 5 plus 3, 8. Square root of 8 units, which is basically 2 root 2 units. Done. Let's look at the next question. Question number 2, part 2. The question says, find the distance between the origin and the given point. So we know origin, what are the coordinates of the origin? Origin is equal to 0, 0 and the other point is negative 5, negative 12. So we know the distance formula, which is x2 minus x1 whole square plus y2 minus y1 whole square, the square root of it. So this will be negative 5 minus 0 whole square plus negative 12 minus 0 whole square, the square root of this, which is negative 5 whole square, that's 25, negative 12 whole square, that's 144, the square root of this, which means square root of 169, which means the distance is 13 units. Perfect. Simple, isn't it? As long as you remember the formula, distance is equal to x2 minus x1 whole square plus y2 minus y1 whole square. This chapter is extremely simple as long as you remember this formula. Let's look at the next question. The next question that we do is question number 3. Question number 3 is, the distance between the points 3, 1 and 0x is 5. Oh, so this time the distance is given and one coordinate is not given. So let's see how we can look at it. This is basically a simple equation. You have so many variables. One variable will not be given. Everything else will be given. So let's look at this. So distance between 3, 1 and 0x is 5, which means 5 is equal to x2 minus x1, in this case 0 minus 3 whole square plus x minus 1 whole square. I have a suggestion. That suggestion is, in case you have a variable, always keep the variable as the first term, which means never use 1 minus x whole square. Always try and keep it as x minus 1 whole square. We'll have a lot of questions in this exercise and chapter where you would have variables, so I would always recommend keep the variable as the first term. Why? Because when students end up opening 1 minus x whole square, they sometimes commit a lot of mistakes. So that's the only request. Otherwise, if you are able to open it properly, it doesn't make any difference really. So then this will be equal to 5 is equal to 0 minus 3 whole square, that's 9, plus x minus 1 whole square is x square plus 1 minus 2x, and this is square. Now let's square both sides so that I have do not have the hassle of the square root sign. So squaring both sides, I get 25 is equal to x square minus 2x plus 10. I added 9 plus 1 gives me 10. Let's take everything on one side. So it will be x square minus 2x. 25 on this side gives me 10 minus 25. That's negative 15 is equal to 0. Now this is a quadratic equation. Let's try and solve it. So I need to find factors of negative 15, the sum of which is negative 2. Yeah, 5 and 3. So x square minus 5x plus 3x minus 15 is equal to 0. Taking this together, x times x minus 5 plus 3 times x minus 5 is equal to 0, which means x minus 5 times x plus 3 is equal to 0, which means x is equal to 5 or x is equal to negative 3. Now is this, let's check what the points are. So the point is, therefore the point is 0, 5 or 0, negative 3. Now in case you're wondering how come I get two answers, that's the reason I have a graph on this page. So let's look at this point 3, 1. So 3, 1. This is this point, right? So this is 3, 1. And the point which is equidistant from it, no, not equal, yeah, which is the distance is 5, is 0, comma 5, which means here. So this line is equal in distance to this line. So one is on this side, the other is on this side. Similarly, I can have it on any other side as well. So that's why there are two answers. So let's look at the next question. The next question that we solve is question number 4. Let's see question number 4. What does question 4 say? Question 4 is point on x. Let's read the question. Find the coordinates of point on the x-axis which are at a distance of 17 units from the point 11, negative 8. So if it's a point on the x-axis, we've done this before in the previous chapter. If it is a point on the x-axis, which means here, what is the value of y in this case? Y will always be 0 for any point. So you will get questions where the point will be on the x-axis, or let's look at question number 5 where the point will be on the y-axis. For point on the y-axis, the value of x will always be 0. So, right? So for any point on the y-axis, the value of x is always 0, and for any point on the x-axis, the value of y is always 0. So let the point be x, 0. So we've taken the point to be x, 0. We need to find the coordinate of the point which is at a distance of 17 units. So again, distance is equal to x2 minus x1 whole square plus y2 minus y1 whole square, the square root of this. In this case, x2 is x minus 11 whole square plus y2 is 0 minus of negative 8, that's plus 8 whole square, and the distance is given equal to 17 units. Like I said, I always prefer to keep my x as the first term, so I always subtract from x. Now this will be x square plus 121 minus 22 minus 22x plus 8 square is 64, the square root of this is 17. Let's square both sides, so this will become 289 is equal to x square minus 22x plus 120 and 60, 185 plus 185. Let's take everything on one side, so it will be x square minus 22x plus 185 minus 289, that's minus 104 is equal to 0. So now I need to find factors of 104, the sum of which is negative 22. So let's try and look at factors of 104. Let me do factorization. 104 will be 2 into 52. Let's look at another one. So 2 into 26. So 4 and 26. Yes, 4 and 26 gives me 104, and it will also give me negative 22. So x square plus 4x minus 26x minus 104 is equal to 0. Let's group them together. X times x plus 4 minus 26 times x plus 4 is equal to 0, which means x plus 4 times x minus 26 is equal to 0, which means x is equal to negative 4 or x is equal to 26. Let's see if they, what else do they want to know. The question says, find the coordinates of the point. Therefore, the point is negative 4 comma 0 or 26 comma 0. Perfect. Let's look at the next question. That's question number 5. Exactly a similar question, but this time the point is on the y-axis. So let the point be 0 comma y. Right? We know that the abscissa of this will be 0 and the ordinate will, we don't know, so we've taken it as a variable as y. And the distance is given as 10 units. So we know distance is equal to x2 minus x1 whole square plus y2 minus y1 whole square, the square root of it. So in this case, the distance is 10 is equal to x2, again 0 minus of negative 8, that's plus 8 whole square, plus y2, which is y, minus 4 whole square. This will be 64 plus y square plus 16 minus 4 into 2, that's 8y. Squaring both sides, I get 100 is equal to 64 plus 16, that's 70, 80. 80 plus y square minus 8y. So I get y square minus 8y minus 20. If I take 100 on the other side, gives me 0. This will be 10 and 2. So this will be y square minus 10y plus 2y minus 20 is equal to 0, which means y times y minus 10 plus 2 times y minus 10 is equal to 0. Y minus 10 times y plus 2 is equal to 0, which means y is equal to 10 or y is equal to negative 2. Let's read the question and figure out what do they want. They said find the coordinates of the point. Therefore, the point is 0 comma negative 2 or 0 comma 10. Wonderful. Let's look at the next question. The next question that we do would be question number 8. No, not 8. Question number 6. We haven't done question 6 yet. Sorry. Question 6 is a point A is at a distance of root 10 units from the point 43. So the distance between A and root and 43 is root 10 units. Find the coordinates of point A if ordinate is twice its abscissa. Now here I would like to remind or revise what we've done. Whenever you write coordinates of any point, you write x first and then you write the y coordinate. This is known as the abscissa and this is known as the ordinate. We've done this in the previous chapter. So here they're saying ordinate is twice as abscissa. So we do not know either any of the variables. So let's say let coordinates of A, B. They say ordinate is twice abscissa. So abscissa is x, then ordinate is 2x, because ordinate is given equal to 2 times the abscissa. So now the distance between x comma 2x and 4 comma 3 is given equal to root 10. So d is equal to x2 minus x1 whole square plus y2 minus y1 whole square, the square root of it. So here distance is given equal to root 10, which is equal to x2, in this case x minus 4 whole square plus y2, in this case 2x, minus y1, in this case 3 whole square, the square root of it. Let's move and solve this. Let's open this bracket and see how it works. So root 10 will be equal to x square plus 16 minus 8x plus 2x whole square, that's 4x square, plus 3 square, that's 9, minus 2 into 2x, 4x minus 12, that's negative 12x, and the square root of this. Squaring both sides, I get 10 is equal to x square and 4x square, that's 5x square, negative 8x and minus 10, 12x, that's negative 20x, and 16 and 9, so that's plus 25. So 5x square minus 20x plus 25. Let's take everything on one side. So I get 5x square minus 20x plus 25 minus 10, that's 15, is equal to 0. Divide both sides by 5 because all three elements have a common factor of 5. So it will be x square minus 4x plus 3 is equal to 0. I need to find factors of 3. So it will be negative 4, 3 into 1, that will be 3 into 1, so that should give me negative 4 as well. Perfect. So x square minus x minus 3x plus 3 is equal to 0. Grouping them together, x times x minus 1 minus 3 times x minus 1 gives me 0. X minus 1 times x minus 3 gives me 0, which means x is equal to 1 or x is equal to 3. Let's see if this is correct. What else is given? Only that no other conditions given, so we need to find the point. Therefore, the point is x comma 2x, which means if x is equal to 1, then 2x will be equal to 2, or if x is equal to 3, then 2x will be equal to 6. So the point is either 1, 2 or 3, 6. Let's move on and let's solve the next question, which is question number 8. Question 8. Question 8 says, what point on the x-axis is equidistant from the point 7, 6 and negative 3, 4? So again, this is a question on the x-axis, which means the point on the x-axis will be x0. Let the point on x-axis be x comma 0. Right? So the ordinate of this point will always be 0, and this is equidistant from point 1 and point 2. So let's name this point A, let's name this point B, and let's name this point C. So as per the question, what is given is CA is equal to CB. The distance between CA and CB is equal. So let's equate it. I know the distance is given by the formula x2 minus x1 whole square plus y2 minus y1 whole square, the square root of it. So let's square it. CA will be x minus 7 whole square plus 0 minus 6 whole square, and CB will be x minus negative 3, that's x plus 3 whole square plus 0 minus 4 whole square, the square root of it. Let's open this bracket. So this will be x square plus 49 minus 14x plus, that's negative 6 square, that's 36. The square root of this is equal to x square plus 9 plus 6x plus negative 4 whole square, that's 16, the square root of this. Let's square both sides. So if I square both sides, then the square root sign from both sides disappears, which means what I have is x square minus 14x plus 49 plus 36, that's 70, and 85. X square minus 14x plus 85 is equal to x square plus 6x, 9 and 16 is 25. X square and x square gets cancelled. Let's take 14x on this side. So I have 85 minus 25 is equal to 6x plus 14x, which means 20x is equal to 85 minus 25, that's 60. Therefore, x is equal to 3. Let's check what does the question want. The question says what point on the x-axis. Therefore, the point is 3, 0. Perfect. That's my final answer. Let's look at the next question. The next question that we do is question number 10. Let's look at the question. Question number 10 is a point P lies on the x-axis, okay, and another point Q lies on the y-axis. So if it is lying on the x-axis, which means the point will be x, 0, and if it lies on the y-axis, the point will be 0 comma y. Done. Let's read what do they want. Find the ordinate of point P. Ordinate is the second term, so this is 0. That's very simple. And write the abscissa of point Q. Abscissa is the first term. For this, it is again 0. Part 3, it says if abscissa of P is negative 12. So what's the coordinate of P? So P is equal to negative 12 comma 0. And ordinate of Q is negative 16, which means Q is equal to 0 comma negative 16. What do they want us to do? Calculate the length of segment PQ. Oh, there's nothing in this question. Basically, they wanted us to confuse us by writing abscissa and ordinate instead of giving us directly the coordinates of P and Q. So distance formula is x2 minus x1 whole square plus y2 minus y1 whole square, the square root of this. So in this case, x2 is 0, so 0 minus of negative 12, that's 0 plus 12 whole square, plus negative 16 minus 0 whole square, the square root of this. 12 square, that's 144, plus 16 square, that's 256, the square root. This is 200, 300, 390, 400. So this is 400, which means 20 units. Therefore, the length of PQ is 20 units. Done. Let's look at the next question. The next question that we do is question number 12. Let's look at question number 12. Question number 12 says, prove that the points PQRS are the vertices of a rectangle. So you can mark a star on such kind of questions. So you will be asked to prove them to be a rectangle or a square or a triangle, isosceles triangle, maybe an equilateral triangle, or maybe a rhombus or a parallelogram. Let's see. So what are the properties of a rectangle that I know? Yes, the properties of a rectangle are that the opposite sides are equal, but that can also be in the case of a parallelogram. So what's the difference between a rectangle and a parallelogram? Yes, the key thing is that the diagonals in a rectangle are equal as well. So if this is P, Q, R, S, I will have to prove. So what I will have to do is prove that PQ is equal to RS. I will have to prove that PS is equal to QR, and I will also have to prove that PR is equal to QS, which is the diagonal. So these are the 3 times that if I prove, then I will be able to prove that the opposite sides are equal, both pair of opposite sides are equal, and also the diagonals are equal. So if I can prove all this, then I can prove that this is a rectangle. So let's try and look at first PQ. So let's look at PQ. So PQ would be 6 minus 0 whole square plus 2 minus negative 4. So that's 2 plus 4 whole square. That's equal to 6 square, that's 36, plus 6 square, that's 36. So this is equal to 72 units. That's my PQ. Next, let's look at SR. What would SR be? So SR would be negative 3 minus 3 whole square plus negative 1 minus 5 whole square root, which means negative 6 square, that's 36, plus negative 6 square, that's 36, so that's root 72 units. Perfect. Therefore PQ is equal to SR. Done. First part done. Now let's look at the second part, which is the second pair of opposite sides. The second pair of opposite sides are PS. So PS will be equal to P and S. So negative 3 minus 0 whole square plus negative 1 minus of negative 4, that's plus 4 whole square root. This will be negative 3 whole square is equal to 9, and this is negative 1 plus 4, that's 3 square, that's 9. So this is equal to square root 18 units. Done. So I have taken PS. Now let's take at QR. QR is equal to Q and R. So that's 6 minus 3 whole square plus 2 minus 5 whole square, the square root of this. So this will be 6 minus 3, 3 square, that's 9. 2 minus 5, negative 3 whole square, that's 9. So this is equal to square root 18 units. Right? So therefore PS is equal to QR is equal to square root 18 units. So I have also proven that the second pair of opposite sides are also equal, and in this case it was equal to root 72 units. So I have proven that this side and this side are equal, PS and QR are equal. The only thing now remaining for me is to prove that the diagonals are equal. Now let's try and look at the diagonals. So diagonal SQ, so SQ will be equal to 6 minus negative 3, that's 6 plus 3 whole square, plus 2 minus negative 1, that's 2 plus 1 whole square, the square root of this, which is 9 square, which means 81, and 2 plus 1, 3 whole square, that's 9. So this is equal to square root 90 units. Let's look at the second diagonal, which will be PR. So PR will be equal to 3 minus 0 whole square plus 5 minus negative 4, that's 5 plus 2, 5 plus 4 whole square. So 3 minus 0 whole square is 9. This is 81. So this is equal to root 90 units. So therefore diagonal SQ is equal to diagonal, the other diagonal is PR is equal to root 90 units. So since both pair of opposite sides are equal, so writing the reason is important. Since both pair of opposite sides are equal and the diagonals are also equal, therefore quadrilateral PQRS is a rectangle. Perfect. Now in case you had to prove it to be a square, how would you prove it? Well, in the square you will prove that all four sides are equal, and then you will also prove that the diagonals are equal. So that's what you will have to do, right? Homework questions. Homework from my side would be question number 1 part 3. Next would be question 7, question 9 and question 11. So 4 questions. Question number 1 part 3, 7, 9 and 11. Thank you so much. Take care. I'll see you in the next video. Bye bye.